Alright, so today we're going to start with cyclohexanes and chair conformations before we start the 2006 test. Basically what this means, this is the chair conformation. It's what she put on the nomenclature part of your test too. Pretty much this is exactly the same thing as this. Okay? It's just a different way of showing it. It lets you see the positioning of the substituents around the 6-carbon chain, okay? So just know that there's 2 different ways to represent what the cyclohexane chair conformation is gonna look like. You can number them any way you want, but this is how I've been doing it since I was in ortho and I never get them wrong. So you can, if you come up with another way for you to number them, that's fine. You can stick with that. But this is how I'm gonna be doing it. Okay. So we'll just do the question that is on the 2006 test. We'll go ahead and write this. So she has one with 3 wedges on it. Okay. And then she has another one that is almost the same, except the last 2 are on dashes. And this one was a methyl. This one was a ethyl. Actually, it was a propyl. 1, 2, 3. Also, this one, same thing. They're pretty much the same. So I did them in line angle. She did them in the actual structural way of writing it out. She wrote CH2, CH2, CH3. That's pretty much exactly what this is. And then this is just one methyl. Okay. So whenever you see a wedge like this, if it's filled in, this just refer it to meaning up, okay? And whenever you see a dash, just refer that to meaning down, okay? The first thing you want to do with these is to draw the cyclohexane chairs so that you don't have to really think about it. You just have it on here and then you just apply what you see onto the chairs. So we draw the first chair like this, okay? And then number them so like this. And then these that are angled in an angle, these are referred to as the equatorial positions, okay? This is very important, guys. And this over here is known as the axial position. The first spot has the axial position pointing down. The second one has the axial position pointing up, and then the same is flipped for the equatorial. The equatorial is up here, and the equatorial is down here. And if you go to 3, it'll flip again. The equatorial is up, axial is down, so on and so forth, okay? And the way I numbered it was this first one on the bottom is 1, 2, 3, 4, 5, and 6. Now, if we were to flip this up, the 1 would then go up, the 2 would be on the bottom, the 3 would then be on the bottom, this 4 would be on the bottom, and 5 would be on top. Pretty much this is the same thing, just inverted up, okay? So the same thing with this, you do your numbering and your drawing of your axial and equatorial positions. See how this axial is going up, 2 is going down, and then pretty much that's how it is. You have to keep alternating with axial up, axial down, equatorial up, equatorial down, okay? So let's take what we have on these structures given to us on the exam for 2006 and put them onto this, okay? Now, when you're doing chair conformations, the way you number them does not matter because you're not doing nomenclature. Number matters in naming, right? But for cyclohexane positioning, the main thing is you just have to make sure that if this is on 1, your next one has to be on the one right next to it. It doesn't necessarily mean that this has to be number 2. It just means that you can't, like if you put this on 1, you have to put it directly next to it. You can't skip one and say, okay, I'm putting this one here, because that's not following how the cyclohexane is drawn. So I'm going to number these like this. 1, 2, 3, and same for these, okay? So this one right here is 1, it's on a wedge, so it's going up, and this is a propyl group, okay? So I'm gonna put that group, I'm just gonna write 1 here to save like time and space for me. I'm not gonna draw it on here, but you're supposed to draw it on here, like the actual group, okay? I just put 1 for 1 right here. 2 is a dash, meaning it's going down. So this group, 2, you see that this is up, this is down, so the 2 is going to be over here, okay? 3 is also going down, so that means you put this third group on 3. So 1 was going up, that's why I put it here. 2 is going down, that's why I put it here. 3 is also going down, that's why I put it here. Does that make sense? So you just have to make sure what's up, what's down, okay? I'm gonna take this same stuff I did and put it on this chair, all right? 1 is going up, 2 is going down, and 3 is also going down, okay? So when you draw these, the first thing you have to do is to see, okay, which one is the more stable chair conformation that I drew, okay? And the way you determine that is the one that has the most equatorial positions is the most stable one. And if there's a tie, let's say there's 2 equatorials on this one and 2 equatorials on this one, then you look at what those groups are that are in that equatorial position. So for this one, how many are there in the equatorial position? There's 3 spots, so how many of them are equatorial? Exactly, so this one, this group 1, and this group 2 are in equatorial position. This group 3 is in an axial position. And over here, what's the difference over here?
1 equatorial.
Yeah, so we have 1 equatorial here, and then 2 axials.
Wait, I don't get the difference between equatorial and axial.
So yeah, I can show you again. So the equatorial is the one that's at an angle.
Oh.
The axial is the one that's going 180 degrees up or down.
Oh, okay.
So the axial is right here, and the equatorial is right here. So if you look over here, don't look at what's up and down, look at the direction. So for this, people might like, oh, it's pointing up, it's equatorial. That's wrong. Because it's going straight up 180 degrees, that means that it's always axial. And so the positioning in terms of up and down can always be different, but you just have to look at what's angled and what's not. Okay? All right, so far we drew the most stable one for this one, which is right here, because we have the 2 big groups, which are 1 and 2, compared to this CH3, these are bigger, right? Right? So that's why we know that we want the most ideal situation for these to both be on an equatorial position. So that's why we know the more stable conformation for this structure is right here. So I'm going to go ahead and erase the non-stable one and carry it on to this chair over here. Does anybody have any questions on that, what we just talked about so far?
For the chair, like, do you memorize that? Like,
Yeah, this is how I always used to do it.
Oh, okay.
Mm-hmm. Yeah. It just requires less thinking. You don't have to think, oh, I put it on axial up here for 2, so that means the axial has to be down here. You know, like I just memorize this structure and I always get it right.
Okay.
You know? Okay. So the next one, we have the wedges on all of them. One has a wedge, so that means this first group is going to be up. Second group is also on a wedge, so it's also going to be up. Third group is also on a wedge, so that will also be up. So if you only draw one chair conformation, like how we just drew over here, and you see that you have 2 axial groups and 1 equatorial, what does that mean when you draw the other chair conformation?
It's going to be, the other one's going to be the more...
Exactly. So anything on axial on the first chair will now be equatorial, and everything that's equatorial now would then become axial. So we have 2 axials here, right? And then, so here's the second axial, and then here's the first equatorial. So if we draw this inverted, I'll draw it right here. 1, 2, 3, 4, 5. Notice I numbered it the same exact way I numbered this one. Okay? Your numbering has to stay consistent. It doesn't matter how you started, but all the chairs have to be consistent. Okay, that's the important part. Okay. So 1 is up. So 1 is up. 2 is also up. 2 is up. 3 is also up. So 3 is up. So right here we have the 2 equatorials and the 1 axial. Just also make sure that what you draw is consistent, right? And just check with it. If you have this equatorial here and you draw your other one and it's not axial, that means you did something wrong. So it's a good thing to just double check with what you're doing. Some people say, oh, I just do it in my head. That's fine, but I always drew 2 to make sure I'm like getting the right structure. So these 2 are the more stable ones because they have the equatorial position. So on the test, it has these 2 structures drawn out, and then it has a box underneath each structure, and it says to draw the stable conformation. So you draw this one for this one, and then this one for this one.
How do you know which ones to circle?
You're not supposed to circle anything on the test for this. I just did it for y'all to see which ones were equatorial. So
you just said memorize how you drew them, and it's
Yeah.
the easiest way to.
mm-hmm. And for ease of writing and for time's sake, I didn't draw the actual substituents coming off of it. I labeled them. But if you look at the test, she actually you're supposed to write them.
So can
on
you
the
just
arrow.
like show how you?
Sure, yeah, I can do
one,
that,
Just,
no
just
problem.
like one of them.
Yeah, no problem. So like for this one, this was accompanied with this one right here, right?
Yeah.
So I'll put this. Alright. So all the ones that we have to put the actual like substituent on it. So the first one was a CH2, CH2, CH3, right?
Mm-hmm.
So that means you have to draw the same thing onto the structure like this. Just like that. That's all you're doing. You're just writing the structure. You're not supposed to draw it on the line. Just do it like this.
Wait, we have to do this?
Yeah, you have to draw the substituent coming off of it. I just did this for ease. You know what? I'll just do it on all of them.
I have a question on the test. How do you think she's gonna give us the diagram whenever she asks us? Like, is there a certain way she like gives us?
It's gonna
does she give
be
it line,
any. It's gonna
table?
be any type of cyclohexane like
Okay.
this that you just have to convert into a chair diagram.
Okay, and then
Now, if
what question was it? You said you took it from this. I just want to see how she like
Mhm.
wrote it.
Go
out.
ahead.
Which
What number is it?
This was number 12. I'm gonna erase this and just redraw them with them on it, okay?
So you said the more equatorial
that's easy.
The better.
Oh,
The
you
more
want- you
stable,
want to draw it out.
yeah,
That's
equatorial
how she's gonna put it on the
is
test.
directly related with
Which one's the more
stability,
stable one?
right?
Whichever one has the most equatorials.
This is the same
And
one.
equatorial is like the
The
one
top
that's
one.
going. No, these are axial. The one that's 100 degrees, 80 degrees
these
up
are-
and down is axial, and then the ones like to the sides are like equatorial.
This one has two, this one has one.
I didn't have time to print out the copy.
Okay, so the left one
Okay. So 1 was up, and this is a CH2, CH2, CH3, okay? So 1 is up, CH2, CH2, CH3, okay? This group over here has a understood dash, right? So what is on that dash?
An H.
Exactly. Okay? I'm not gonna draw, well, you're supposed to draw it actually, so yeah, just draw it.
So on the test, they want us to draw that.
Yeah. Mhm. So for 2, we're going dash down, same group, but down.
Wait, that's 15 extra hydrogens. Okay.
Okay? 3 is also down. That's just a CH3. H, H. Okay? So what's on the rest of the spots that we didn't draw.
Just hydrogens.
Exactly.
So it's necessary on the test that even on the spots that don't have like the ones like that don't have the
Technically,
constituents.
if you don't draw anything else, like if you didn't draw these H's on it,
Yeah.
you would be okay. Because they're supposed to be understood H's if you don't draw them. But if you draw it on one spot and you don't on the others, then that
That's
might
when-
be problematic with grading and stuff. So if you're gonna do it all. If you're
What
not,
do you recommend? Just
Just do it.
I think just doing it will help. I mean, it won't hurt you,
okay.
right?
If you
But
don't-
if you look at the key, this person, he did it, but he only drew the H's on the spots that had a substituent on it.
Yeah, that's what I was wondering. Like,
Yeah, so that's technically not Bean's way of wanting to see you write the answer, but this is for sure like,
Correct.
correct.
And
You know?
if you number them out, will she take points off or will she not care?
If you number them out.
Like 1, 2, 3, 4, 5, 6?
No.
No.
Why would you take out? No.
I was just asking.
No. So did everybody draw those chairs that I drew in the beginning?
Yeah.
Like with the orientation, the lines on them, and the numbers?
This one's for the
What?
first one, right?
Yeah, this one's for the first one.
Yeah.
Why did you flip the other one?
So you're supposed to flip it to compare it to see which one is more stable. When you have a structure, you want to draw both formations. Some people think about it in their head. You can do that. I'm not going to say don't do it, but I don't do that. I just draw both of them and compare. We
For
have
each one?
for each one.
Okay.
Yeah. So technically you're drawing 4 chairs
Okay.
and then drawing the more stable one in the box.
Mhm.
Okay, so we can, I'm not, like, at this point, I don't even have to draw the next one. Say this was the first chair I drew, and I saw that the biggest groups on the substituents were both equatorial. That already tells me that this is the more stable one because the other group is just a methyl. And the opposite of that will be both of these on axial and this one on equatorial, which we don't want. We want the biggest bulky groups on the most equatorial positions possible. That's what is going to make you know, help you know what the more stable chair conformation is. Okay? So now that we did this one, we don't have to do this one on the test. We can just do everything else now. Anybody have any questions? So just a quick takeaway. No, wedge means up, dash means down. Equatorial
What does that mean when you draw it on the chair?
over here.
Yeah, like the up and down,
Okay. So this means what?
up.
Yeah. So then we're going to go to 1 and see which position is up. So which one of these is up? This one, right? So that's how we know that this one's going to go here. 2, this is going
And down.
down. So we go to 2. Which one's going down? This one or this one?
That one,
This one. So that's why I picked this one. And so on and so forth for 3. This is going,
down.
and 3, you put it down.
Okay.
Okay? So takeaways, wedge means up, dash means down. Equatorial means not going up and down because the equator goes like this, right? So you can think of it like that. The equator is not up and down. It's like this. Okay, so that's why the one going up and down is referred to as axial, and the one going in the angle is referred to as equatorial, going on the equator. You can remember it like that. What's up?
If there was 2 equatorials and 2 axioms, it wouldn't matter which.
No, it does. Then, so like if they're the same, then what you look at then is what those groups are. Like let's say 2 of them were CH3s and 2 of them were CH2, CH2, CH3 like that. You'd want the CH2, CH2, CH3 to be on equatorial as most as possible. Your ideal situation is for the biggest, heaviest groups to be on that equatorial position. Okay? So just remember that and remember the format of how I drew it and you will never get it wrong. Can I erase this?
Mhm.
Alright. Now we can follow the order of the test now. I just wanted to cover this first because this was the last thing that I did not go over yet from the weeks prior leading up to your exam. Okay. So the first part of your test from today, from this Friday all the way up till Orgo 2 next semester, your first section is always nomenclature, okay? So she's gonna give you a structure, or she'll give you a name, like that last one, and she'll tell you to draw it or write what the name is, okay? So what's the rules that we know for nomenclature, guys?
Longest chain, continuous chain.
Yes, we want the longest continuous chain, and trying to find that, we also want to have the most number of substituents simultaneously trying to get that longest chain. Okay. So yeah, get the longest chain, start at the closest part to the first substituent possible, and you want the most number of substituents possible trying to make that longest chain at the same time. So, which way would be incorrect to start numbering from?
Left to right is wrong.
Exactly.
We have to start from the top right.
Exactly. So if you start from here, 1, 2, 3, 4, 5, 6, you're not going to get a first substituent until number 6. Your number for your substituents you want to be the lowest possible. Okay? Doing it from here, it doesn't matter which side you start from because they're both identical on both sides. 1, 2, 3. So that is better than this, but let's compare the rest.
Are we on the test or?
Yeah, this is 2006. Yeah, this is the 2006 exam number 1A. Okay, so we have to try these now. So 1, 2, so we have it on 2 over here, as opposed to having it on 3 here. So now we have to see which one gives us the longer chain. Okay, 1, 2, 3, 4, 5, 6, 7. So we get 7 that way, or 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, this seems like it might be right, but let's try this way now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which way is the right way to count?
10.
Exactly. So the first priority you want is to have the longest chain possible, okay? I know that this gives you a substituent on 2, but that's a secondary priority. Your primary priority is to have the longest chain with the lowest number of a substituent possible, okay? So we're going to start from right here. 1, 2, 3, 4, 5. Which way do I go?
To the right.
Right.
Yes, you don't go this way because you're going to have a smaller chain. 6, 7, 8, 9, 10. So what's my parent going to be?
Decade.
Yes, so the best way to do this before you write your answer in the box, I always write decane or whatever the parent is, and then put a line underneath it, and then I start writing the substituents under it, so I know what I'm working with, okay? So where's my first substituent?
3.
3.
What is it?
Methyl.
Okay. So the first one is 3-methyl that I find. Where's the next one?
5.
5.
Okay. Next one is 5. Does anybody know how to do this?
I know it's pencil, but I don't know what to think.
Pentyl.
So,
You can do it
what
two
does
ways, right?
pentyl look like?
1, 2, 3, 4, 5. But it's connected on the third
So you
one,
can
so it's
split it up,
terpentyl.
right?
So, let's say this was this. Let's say that this 5 was this. Then what
That's
would it be?
iso, propyl, yeah, I'm so sorry.
right? Don't say sorry.
No, I just yeah. Peas.
Alright,
peas
so
and
this would be
peas.
iso. Iso pretty much means it's gonna be forked at the end, like that. Okay, that's what forked means. But our structure, she tried to play with this. She tried to play with y'all like on this test, or whoever. Zaid Farad, she took it in 2006. She was like, "Oh, let me make this little thing and make people think it's an iso, but it's not." So what this is a substituent on a substituent. Okay. So.
Oh,
Where's
it's a
it?
butyl? No, it's a propyl with.
So how many carbons are there in the one continuous chain off 5?
3.
Okay, we do a different color.
It's an
Oh, so it's gonna be
So-
You split it up.
and then you just do like parentheses, right?
Yes, 1, 2, 3, right? So where is the substituent off the substituent here?
There's an ethyl off the 1.
Off of 1.
Exactly. So this 5 has a substituent. Within that 5, there's another substituent, right?
Mm-hmm.
And that first substituent is on the first part of that substituent. That's why you start with 1 here, okay? Now, what is that substituent coming off that 1? Exactly. Ethyl. You write the substituent before the substituent that it's on. And the substituent that it's on is what?
1. Oh.
I mean,
Propyl.
the
Propyl.
propyl, exactly.
Wait,
I should put this on this. I don't know why I didn't do that. What's up? You have a
Who's
question?
on?
It just turned on.
Do you have a question?
it's on purple. Wait, how?
So I'll tell you right now. One second. Turn this damn thing on.
Is there more than one way to name that?
There is, but this is the most concise way to do it.
Okay.
Actually, there isn't because there isn't a particular name for just this structure here. So, yeah. Because this one has like 1, 2, 3, 4, 5. We know what sec-butyl looks like, right? If this was like this, then it would be sec-butyl. But because it has an extra one off of it, we can't use that type of naming strategy to name this structure. Okay, so what we're doing is we see that there's a substituent on 5, right? We know that, right? And the longest continuous chain going in one direction is,
Decane. Oh.
from the substituent,
Propyl.
is 3, right?
Oh,
And that's what the substituent's name is. It's like the
Oh.
parent substituent. You can think of it like that, okay? So that's why we know that it's going to be propyl, and within that propyl, there's an ethyl substituent on the first part.
oh,
Does that make sense?
yeah.
Okay. So that's what we have right there. So do we have all our substituents? Are we missing anything? No? Okay, good. So what we're going to do now is see which one is going to go first in the actual naming. So does anybody know what to look at for that?
The first
Alphabet?
letter.
Yeah. So you're going to look at M and you're going to look at E. If you ever ask yourself, oh, wait, which letters count? Because some don't. Just know this. Nick counts. N stands for neo. I stands for iso. C stands for cyclo. If you ever have a prefix in front of ethyl, propyl, butyl, or whatever it is, and it's one of these three, then you take these three into account for the alphabetical arrangement of the actual name. So, which one's gonna go first?
Okay.
Yeah. So we write the substituent that it's on first. Then in the parentheses, you go forward and say what that substituent has on it, and then what that main substituent was. And then you go to the next one. Okay. So the final answer for that one is 5 dash parentheses 1 ethyl propyl dash 3 dash methyl decane. Okay, next one. So what's the parent for the next one, guys?
Cyclohexane.
Yes, sir. So just remember, this means this. Okay? It's a 6-carbon ring, okay? All right. So we know that the parent is going to be cyclohexane. Now let's go with the substituents. Now what I do for these is I don't look at the numbers right now. I look at the numbers last, okay? So what are the substituents coming off of these, this chair diagram?
Secpentyl and
So in the class, she never talks about sec-pentyl, but she does talk about sec-butyl. So, and she hasn't ever used the actual IUPAC name for sec-pentyl. She only goes to butyl. So I would definitely recommend to go the other way of naming this, because after sec-butyl, she doesn't go any further. She does go further in terms of just like a regular pentyl or like a cyclopentyl or like stuff like that. But when it comes to the sec means secondary, she doesn't go past it.
Sec is when it splits.
when it's on the two.
So sec stands for secondary, okay? So we know that this group right here is a, this is 1, 2, 3, 4, 5. If this was just like this,